Okay, so in the last video, I had suggested trying numbers 1 to 5 on this sheet. Seems wrong to waste the backside of a sheet, because it does seem wrong to waste the backside of a sheet. Okay, so I'm just going to go over them now. Hopefully they didn't cause too much issues. So number 1 is two students who are skating. And one is Sam, and one is Madison. And it says Sam is skating at 3 meters per second when he passes Madison, who is just finishing adjusting her equipment. So Sam's VAV is 3 meters per second. Madison's VI is 0. She takes off immediately after Sam, accelerating at a rate of 0.8 meters per second squared. How long before she catches up to Sam, and how far have they traveled? So we're looking for delta D and delta T for both of them. We don't know what the delta D and the delta T's are, but we know they're the same. So we know that delta D of Sam equals delta D of Madison. So if we go over here, the delta D of Sam equation is just going to be VAV delta T. And the delta D of Madison equation, because there's a V and A, has to be VI delta T plus 1/2 A delta T squared. But the VI delta T term is going to go to 0. So now we're going to take this, and we're going to take this, and we're going to fill them in up here. So Sam's was VAV delta T, and Madison's was 1/2 A delta T squared. And now the only thing we don't know is the delta T. One equation, one unknown. We can find it, divide both sides by delta T. So you'll have VAV is equal to 1/2 A delta T. To get the delta T alone, multiply by 2, divide by A. Okay, and now fill in your numbers. So 2 times, the VAV was 3 meters per second, and the A was 0.8 meters per second squared. So 6 over 0.8 should be 60 over 8, 7.5 seconds is my time. Okay, so that's how long it takes to catch up. But then it says how far is each traveled. So now go back over here, and for Sam it's going to be 3 meters per second times 7.5 seconds. So it's going to be 22.5 meters. And for Madison, it's going to be 1/2. A is 0.8 meters per second squared, and 7.5 seconds squared. So 0.4, 7.5. Lo and behold, it ends up being 22.5 meters. Do you need to do both? It's always good to do both, because that's your check. If they're the same, then you're right. If they're not the same, then you screwed up somewhere. All right, number 2. A student is driving 64 meters behind his favorite physics teacher. So here's one car. And here's the other car. So this is the student, this is the teacher. This distance in here is 64 meters. Okay? They are both traveling 15 meters per second initially. So VI, 15 meters per second, VI, 15 meters per second. The student gets tired of going so slow, so pulls out to accelerate. So the A of the student is 3 meters per second squared. The physics teacher innocently accelerates, of course, would never do this on purpose, 1.4 meters per second squared. How long does it take for the student to catch the teacher? How far have they both traveled? So the student isn't going to catch the teacher in 64 meters, because by the time the student has moved 64 meters, the teacher isn't there anymore. The teacher's somewhere up here. So this is delta D of the teacher, and this is delta D of the student. And from the picture then, hopefully, when you look at it, you can see, well, then delta D of the student has to be equal to delta D of the teacher plus, that's a plus, 64 meters. Okay, so now we need an expression for delta D of the student. We have a VI and an A, so it's going to be VI delta T plus 1/2 A delta T squared. And we need an expression for delta D of the teacher, and it's going to be VI delta T plus 1/2 A of the teacher delta T squared. We don't know the time, but we know they'll be the same. So if we take these two equations and plug them in over here in this equation, right, so where the student is, we'll write VI delta T plus 1/2 A of the student delta T squared is equal to, and for the teacher we'll write VI delta T plus 1/2 A of the teacher delta T squared, and then we have to keep our 64 meters. Now this might look messy, but check out the VI's. They're the same, which means these two VI delta T terms, one on either side, are going to cancel each other out. So really we're going to be left with 1/2 A of the student delta T squared equals 1/2 A of the teacher delta T squared plus 64 meters. That is more manageable. You're solving for T, it's the only thing you don't know, so bring this over to the other side. 1/2 A of the student delta T squared minus 1/2 A of the teacher delta T squared equals 64 meters. Factor out your T squared term. 1/2 A of the student plus 1/2 A of the teacher, whoops, except it's a minus, equals 64 meters. Divide by the bracket. So T squared will equal 64 meters divided by 1/2 A of the student minus 1/2 A of the teacher. So 64 meters divided by 1/2, the student was going accelerating 3 meters per second squared, minus 1/2 the teacher 1.4 meters per second squared, 1.5, 0.7, 0.8, 80. Take the square root, so it's going to be close to 9. Delta T is 8.944 seconds. That's the first part of the question. The second part wants to know how far has each traveled. So to find out how far each has traveled, you come back over here for the student. It's 15 meters per second times 8 we're just using this equation, 8.944 seconds plus 1/2, 3 meters per second squared times 8.944 seconds squared. Punch this in your calculator and you should get 254.157 meters. That's for the student. How about for the teacher? So now for this one, we'll fill it in. Delta D of the teacher is equal to 15 meters per second, 8.944 seconds, plus 1/2, 1.4 meters per second squared, times 8.944 seconds squared. Punch this in your calculator and you should get 190.154 meters, if you haven't rounded your time too much. Take a look at the difference. Look at that. There's 64 between them. You must have done it right. All right, number 3. Number 3 says there are 2 students in a pool. So student 1 and student 2. They're 100 meters apart. They are starting from rest. So VI for each of them is 0. When they start, one accelerates at a rate of 1.5 meters per second squared, the other at a rate of 1.2 meters per second squared. It wants to know how long before they meet. That should be the same for both. And how far has each traveled. That is not going to be the same for both because one's accelerating faster than the other. So for this person, it'll be VI delta T plus 1/2 A1 delta T squared, but the VI goes to 0. And for this person, VI delta T plus 1/2 A2 delta T squared, but their VI goes to 0. How are their delta Ds connected? Well, it says they're 100 meters apart in the pool, and they head towards each other. So that means delta D1 plus delta D2 should equal 100 meters. So now sub in 1/2 A1 delta T squared from down here, plus 1/2 A2 delta T squared equals